Okay, number three is going to be an interesting problem. I want to point out that something we really haven't mentioned at this point, but we're listing what's called a principal root. And unfortunately, um, I'm going to claim that, the square root of the number here, this is the number here, equals this, but it actually also equals this. I'll write that down for you. It's the opposite of that number, minus 5 plus I root 7. All right? Now, granted, we do discuss principal root. As time goes on, though, a square root is going to have two roots. All right? A cube root will have three roots. A fourth root will have four roots, so forth and so on. So I'm going to say the two legitimate answers over here, this is one of them, and this is the other one. And this is what Wells is referring to as the principal root. All right? But there are two. So what I want to do is I just want to square this guy and show you when squared, it gives me back that over there. Just like if someone said, what's the square root of 4? And someone were to say, oh, minus 2 is one of the roots. And the reason for that, because minus 2 when squared gives you 4. But what's the other root going to be? And this is called the principal root, would be 2. Why is that? When you square 2, you get 4. All right? Let me erase this over here. And let me just go through this, kind of carefully. I want to square both of these guys. So if you square minus 5, you get 25. If you square I root 7, you would get 7I squared. And then you would get minus 2 times 5, 10I root 7. All right, what does this give you? 25 minus 7, which is 18. And then I'm going to write this a little bit differently so it matches what I have over there. I'm going to say 5. I'm going to bring the I on the inside, which would be minus 1. And I'm going to bring a 2 on the inside, which would be a 4. And that would give you minus 28. All right, gives us back what we want. If you square this one, what do you get? 25 plus I squared times 7. And then you would get minus 2 times 5. Whoops, I should write 10 instead, right? And then what do you get? Well, let's see, you get I root 7. Are we getting the same thing? We sure are. We're getting 18 minus 10I root 7. All right, we're getting the same thing each time. This results in 18 minus 5 root minus 28. Right, same thing. All right? So, again, our intent here is not to confuse you. And although Wells does not dwell on it, I want to go back to the first problem. And the first problem, we got this answer. And my claim is if we get this answer here, that's the principal root. I could also write this one down. Minus 4 minus I root 3. All right? Now, by the way, I'm going to say they're both legitimate. And when you go further in mathematics, both are written down. All right? Now, certainly in algebra, when we write down the square root of 4, we want the principal root, which is 4. And also here, we're going to get the principal root as well using Wells's technique. All right? But I want to square both of them and see what happens. This would give me 16. And this would give me I squared times 3. And then I would get what? Minus, let's see if I get that. Well, no, it's going to be plus 8I root 3. Okay, let's do this. This is going to be 13. Well, let's take a look at this. I'm going to bring it on the inside. And that would be, on the inside, would be minus 64. That would be minus 192. Worked out like a charm. If you square this one over here, what do you get? You get 16 plus I squared times 3 plus 8I root 3. Are we getting the same thing? Of course we are. All right? Therein lies the problem. So I want to point out, I still want to do number 3, not by formula, but by work. All right? The work I'm looking at, I'm going to try to do it step by step. The first thing I would do is I would get the I. So it's minus 38 minus 8I root 30. What do you get over here? Let's take a look. I'm going to factor out a negative number because I'm still looking for an I. And I would figure out minus 2. What would that give me? 19 plus 4I root 30. Well, I'm still looking for that I. And what do I see over here? Root 2 I. And let's write this, what's remaining over here. It's going to be 19. And I think you know by now I like the 2. So this would be 2I. I'll bring a 4 on the inside, it's 120. All right? What am I going to do now? I'm going to work on this and see if I can do it. All right? So what am I going to do over here? Let me write it down for you. That's 19 plus 2I root 120. I can make an assumption. And I want to point out when you square a problem, it does create problems, by the way. And what I mean by that, if you square minus 2, you get 4. And if you square 2, you get 4. Right? That does present a problem. I know that. So I'm still going to do it. All right? What do you get over here? And in the past, we haven't had much trouble with it. Also, in the past, it was very easy to reconcile what the principal one was. And the reason for that was that we were looking at numbers we understood really well. All right? Now, complex numbers are a little bit more difficult to understand. So I squared the left side. And the right side, when you square it, what do you get? You would get A minus B plus 2 root AB I. Now, what do I know? I know A minus B is equal to 19. And I know, let's write this down. Let's see, AB would be 120. Now, by the way, I certainly am challenged by this as well, but this is something we've been doing for some time. And, you know, kind of looking at it, let's take a look for the 120, right? So 120, I could say, you know, 10 times 12. That's certainly not going to be a difference of 19, though, is it? And then what could I do? Let's take a look. And I don't know, let's do 5 and 24. Well, 5 times 24 is 120, and they do differ. Right, so I'm going to say A in this case over here is 24, just looking at it. And the B in this case over here is going to be the number 5. 5 times 24 is 120, and 24 minus 5 is 19. So I'm pretty comfortable to saying that I know what the A and B is now. So let's write this over here. And this is 19 plus 2I root 120. And I'm going to claim a root of that is going to be the square root of 24 plus the square root of 5I. All right? Now, certainly, I'm not going to square it to verify that, but what I want to do is go back and put it up here. All right? So I'm going to write this down now. I'm going to write down root 2I, and I found this to be the root of 24 plus the root of 5I. I'm going to erase my work over here. I no longer need it. I'm done with this. I'm done with this. I'm done with this. And I'm done with this. I want to multiply it out because I want to get in that A plus BI form. What are you going to get? The root of 48I plus the root of 10I squared. What does this give me? Minus root 10 plus, well, let's see, that's 16, right? And that's going to be 4 root 3I. So I'm going to claim that's the root. All right, now someone says, that's not the answer you have listed, and you're right about that. There's another one. And why is that? When I square either this number, and it's going to be 2 roots, by the way, it's the same as squaring this number over here. It's opposite. Which one did I find? This one. Now, Wells would claim that's the principal one, but there's two. All right? Either one you get, as far as I'm concerned, is good to me. Now, someone says, oh, you were lucky in the past getting his principal root. And you're right about that. I was lucky. Now, going back when we weren't dealing with complex numbers, though, these were much easier to resolve which one the principal one is. All right? I'm not going to say there's any steadfast rule about which the principal one is. I'm going to say there's two of them. All right? There's two of them right there. We got both of them. All right? Thank you.